Hey everyone, Geophysicist Stefan Burns here. California is due for a big earthquake. And it's not a question of if, but when. And even more importantly, where. There are multiple locations in California that are locked and loaded. Of course, you have the main San Andreas Fault running up through California, a right lateral strike slip fault. You have the Pacific Plate here moving northwards. You have the North American Plate moving to the south. But you also have a whole bunch of lesser faults, and some of them haven't had a significant rupture in hundreds of years. Now, the two biggest earthquakes that we have on record are the Fort Tejon earthquake, 1857. We see that right here. That was a magnitude 7.9. That was a very big rupture. And then also in 1906, of course, the famous San Francisco earthquake, and that was also calculated to be about a magnitude 7.9. Though there is a little bit of discussion there. It could be maybe a little bit weaker, 7.7. Some people have it in that magnitude 8 range. Regardless, the slip of the San Francisco earthquake was about 6 to 8 meters for the Fort Tejon earthquake. The overall plate motion, that slip from before then after the earthquake was 4.5 to about 6 meters maximum. So in the blink of an eye, effectively, geologically, you can have a massive amount of plate motion, and on a geologic scale, that is causing parts of the Pacific Plate here, which we know as California, clearly like all this part here to the west of the San Andreas Fault, to slowly march northwards. We see that very clearly actually in some of our geology. For example, Point Reyes here. You have the San Andreas Fault cutting directly through Tamales Bay. Beautiful area if you've ever been to Point Reyes. You'll see here the Point Reyes headlands, and this is a rock outcrop, and that has this sandbar that's kind of created in between other rock outcrops and that one, and that is all marching to the north because of this plate motion. But there are some areas in California that really don't experience earthquakes all that often, but they do have the capability of producing the biggest earthquakes. And then there are other areas that are having smaller earthquakes quite frequently, and then we have some sections that experience continuous creep. And so we can use all this information, though it is fairly limited in a geologic sense, right? We have some historic reconstruction data going back, let's say like a millennium, but in terms of like earthquake records that really started with the California missions, and then of course some investigative geologic work, finding fault traces and mapping that out has extended that horizon further back. But really we have about 225 years of earthquake history in California. So for example, a lot of people know about the Fort Tejon earthquake, 1857. Then you also had a big earthquake in SoCal in 1812. It was actually two earthquakes back to back effectively. We see this one here, magnitude 7.5. That was on December 8th. And then on the 21st of December, same year, so just about 2 weeks later, you have a 7.1. That was the Santa Barbara earthquake. But there was actually a significant earthquake that occurred 12 years before that. So that was a magnitude 7.4. 1800 on November 22nd. The epicenter is not exactly pinned down because that was one of the first earthquakes to occur in California in recorded history. And you also have some earthquakes down here that are quite significant going out into Baja California. So a quick explanation as to what we're looking at before we go further. You'll notice these colors here. This is just, we'll call it light red. This is all the earthquakes magnitude 6 to 6.9. And then you have this regular red color there. That's all earthquakes magnitude 7 to 7.9. If we go all the way up here to our Great Cascadia earthquake 1700 magnitude 9, we'll see a dark red color. There's only one of these on the map. You will also notice some pink colors here. These are the magnitude 5 to 5.9 earthquakes. I do not have all of them shown, just the ones that are important for today's discussion. Then also these yellow icons there are for magnitude 4 to 4.9 earthquakes. Again, just showing them in this region because it's important to show even those lower magnitude 4 earthquakes in that zone. I'll explain why in just a little bit. We also have some of our other geologic factors just for illustrative purposes. Two stratovolcanoes, Mount Shasta. Then we also have Lassen there, And we also have the geysers here, which is a very volcanically active area. California used to be a subduction zone, and there's remnant volcanic activity as a result of that. But let us zone in first and foremost on the location of the magnitude 7.9 in 1857. This was a big earthquake. We see it right here, the epicenter just south of Parkfield. And there's in fact a section of the San Andreas which experiences continuous creep. So we're very unlikely to see any big earthquakes going from, I guess, about Gilroy, you could say, down to Parkfield, which is actually a little bit lower there, but this is really the section where there's effectively no high magnitude earthquakes, and I have these 2 magnitude 6s here bounded on each side. So there's no magnitude 6s in this section there. You'll notice the date on this, 1860. This one there, 1883. And so we're looking back about 225 years with our records here. But this was a massive earthquake, and there was about 4.5 to 6 meters of rupture as a result of this earthquake. And so it went all the way up to Parkfield, as I said, but then went all the way down and went past the Garlock Fault and went basically right to the location of this 1812 earthquake. And so there was no rupture evidence really beyond that, because this had displaced that built up stress just a few decades prior, that being a magnitude 7.5. So 7.5 is weaker than 7.8, but not dramatically so. This was not a magnitude 6 earthquake or anything like that. You also notice some magnitude 7s here that go up into California. Again, I don't have every single magnitude 6 or 7 earthquake shown, but here we see the 7.1 Ridgecrest. This was 2019. We see the 1872 Owens Valley earthquake. Beautiful area, big earthquake back in 1872 is 7.4. So California is very tectonically active, but we're really just looking at the San Andreas today. So the thing with the Fort Tejon earthquake is that it last ruptured in 1857. That's a long time ago. That specifically is 168 years ago. And so a lot of people are looking at that zone as the most likely to experience the next big earthquake, magnitude 7.5 or greater, because the time has just been the greatest since that last big rupture. And we don't exactly know what the reoccurrence interval is for that. And the reoccurrence interval by no means is gospel that, okay, let's say it's 200 years. Well, right at the 200-year mark, you're due to have a rupture. Some faults do seem to be pretty precise in always hitting their reoccurrence interval pretty closely. For example, the Alpine Fault in New Zealand, which is similar to the San Andreas in many regards, but it's not like a complete 100% rule that always happens. So you have to keep that in mind. Then you also have the location of the 1906 earthquake, also magnitude 7.9. And this, in fact, was even a bigger rupture than Fort Tejon. So it was at a depth of about 11.7 kilometers. This is on April 18th, around 1312 Universal Time. And here is the epicenter. But in fact, the shaking went all the way up to Eureka, which is way up here, past where the San Andreas starts to take this jog, and you actually then get this subduction zone there. And you get a lot of magnitude 7 earthquakes, as you can see in this area. I'm not plotting the ones further north, just these ones right near this jog in the San Andreas. So it ruptured this entire length of the fault. And the epicenter, though, was down here, also ruptured down through the Santa Cruz Mountains to some degree. If you study earthquake history, you'll also notice that there was a magnitude 7.4 here in the Santa Cruz Mountains, 1838. And so that is weaker than a 7.9. And the rupture for that went from about San Francisco down to Monterey. So maybe 100 kilometers maximum, more like probably 80 kilometers. That was a big earthquake, but it did not rupture the entire San Andreas going all the way up to Eureka. The shaking in Eureka was actually quite intense. So there were some zones in this area, which is, you'll notice, very quiet. We'll talk about that in just a little bit, that experienced less shaking than Eureka and Arcata, McKinleyville, Trinidad, that whole area. Very powerful earthquake. So those are the two main zones. Now let's focus in specifically on what makes those zones special. Now these zones are special for a couple reasons. You'll notice that there are these locked sections here, and you'll notice that this is where the San Andreas makes a bend. So both there in the south and also up here in the north, you get this bend in the San Andreas. And what that does is it means that the fault does not slip nearly as often as these other sections, especially like the section that's creeping, where you always have some plate motion basically continuously. And for reference also, like the San Francisco Bay Area is regularly getting earthquakes, and also down here in Los Angeles and a little bit lower, they're regularly getting earthquakes in general compared to these two locked sections. But the locked sections and those bends in the San Andreas very clearly show how the geology really influences the earthquake reoccurrence interval and also the maximum magnitude that it reaches. There are a few things that are unfolding here. Because it is locked with this bend, it's not just strike slip motion. There's a little bit of normal motion with this as well. That makes these earthquakes more powerful. And that bend causes the fault to struggle to rupture. But when it eventually does, it's had more time to build up stress, and that can generate a much bigger earthquake. So these are the zones that you want to look at if you are looking to understand where the biggest, highest magnitude earthquakes are going to occur in California and when they may rupture. You have to look at the historic activity to understand that. Now going back to SoCal, we have an interesting progression here. We have this earthquake that occurred in 1800, magnitude 7.4. Then we had our two magnitude 7 plus earthquakes there in 1812, the 7.5 and the 7.1. So you already notice this progression going here and then there. We're moving north. This one not exactly on the San Andreas. It was on some other fault systems, but it eventually did connect in. And then you'll notice here our Fort Tejon earthquake. You will also notice nearby, just most recently, this 1952 magnitude 7.5. And so if you go back in time, 1800, 1812, 1857. Now our most recent earthquake is here. That is our 1952. And our earthquake for Fort Tejon, which mostly ruptured to the south, is pretty close to where this continuous creep section begins. So this did rupture some of that fault, that rupture with the Fort Tejon earthquake, but not to the same degree. So anywhere in this zone really is the highest likelihood for this part of the San Andreas to rupture next, because this 1952 earthquake there did dissipate a lot of that stress, being a magnitude 7.5. But you will also notice if you go back further, that one, 1800, that's 225 years ago as I filmed this now in 2025. Now you will see some others down here in like the Mexicali region. This is a magnitude 7.3 there, 1892. This is a 7.2, 2010. So it looks like that zone is pretty well accounted for. These are close together, nearly the exact same magnitude. So it looks like that area has recently relieved its stress. And if we go up, I'm not showing really any of the magnitude 6s in this region, because if we're interested in big earthquakes, magnitude 7, magnitude 6 isn't really dissipating that built up energy. Again, the earthquake scaling for the magnitudes is, let's say you go from magnitude 6 to 7, that's 32 times more energy released. So you need 32 magnitude 6 earthquakes to equal just one magnitude 7. And let's say it's a 7.5. Well, now you need a whole lot of magnitude 6 earthquakes. And so they could be illustrative for perhaps them being a foreshock, like maybe this is a sign of activity that's building up. But in terms of dissipating the stress on a section that needs to release with like a magnitude 7, 7.5 or greater, let's say, it's not dissipating that stress fundamentally in any significant way. So we have basically this section there really looking prime for a big earthquake at any time. Again, this one, 1857. So it's been 168 years since that occurred. Now, if you go further north, we will see our Bay Area, and there are quite a lot of faults in here that haven't ruptured in a while. Let's check them out. Here we have a graphic from the San Francisco Chronicle, and we see 4 faults here, as well as the San Andreas Fault. We have the Calaveras Fault, we have the Hayward Fault, the Green Valley Fault, and also Rogers Creek Fault. And so all of these are pretty big faults, but they're not going to give you a magnitude 7.9 earthquake. Almost certainly that's not going to be the case. Maybe on a very long geologic timescale, eventually you get that to occur. But in general, the magnitude of an earthquake is tied to the length of the fault and how much of that fault ruptures. So you did have a big earthquake on the Hayward Fault in 1868. That was a magnitude 6.8. And so USGS specifically is really looking at the Hayward Fault to rupture pretty soon. But you also have the Calaveras Fault, Green Valley Fault, and Rogers Creek Fault. And some of them had their last ruptures going way back in time. So Hayward Fault, again, 1868, reoccurrence interval about 161 years. And they think it's going to give us probably a magnitude 6.8 again. That was the magnitude of the last Hayward Fault earthquake. Then we have the Rogers Creek Fault, last major quake, 1745. Possible magnitude for that is a 7.1. That's quite large. This is now starting to reach that zone that has been locked up as a result of this bend there, though this is a different fault than in San Andreas. But as I'm about to show you later, you don't really get earthquakes moving past this zone off the coast of California, which is interesting. Even like lower magnitude earthquakes, 5s and 4s. And then we have the Green Valley Fault. That last rupture with a major quake, 1609. Possible magnitude for that, 7.1. And also the Calaveras Fault, last big earthquake on that, 1740. And possible magnitude, 6.8. Now the Calaveras Fault often gets like these magnitude 5 earthquakes. And so all of these faults have been rupturing with magnitude 2s and 3s and 4s and occasional 5s. But in terms of these big earthquakes, these are the last times that they occurred. So these are 4 faults to watch in addition to the San Andreas in the northern Bay Area. And now we're going to look at the zone that I think has the highest likelihood of rupturing sometime in the near future for a variety of reasons. And this is the section in Northern California going in between San Francisco and the Mendocino Triple Junction. So this is very interesting. Here we see the epicenter of the magnitude 7.9 1906 San Francisco earthquake right off the coast of San Francisco there on the San Andreas. And I've drawn a line going from that magnitude 7.9 all the way up to the magnitude 7 earthquake that is closest to it. So there are no magnitude 7s in our record through this entire zone. And this is the magnitude 7.2, 1992, Petrolia there. We also just recently had a magnitude 7, December 2024. You'll notice a 7.1 here, 1923, 1878, magnitude 7. We also have one a little further south. This is a magnitude 6, the furthest magnitude 6. And then you have to go all the way down here to get a magnitude 6, last one being 1898. Now you have a very interesting sequence of events that unfolded here. So you have a magnitude 4.9 that ruptured 1887. There's a foreshock to this earthquake there, magnitude 5.5 that ruptured in 1888, so 1 year later. And then a decade after that, you have this magnitude 6.7. Notice the location. It's exactly at the bend in the San Andreas Fault. And then I plotted out the magnitude 4 earthquakes as well. So you have this sequence there unfolding over 11 years. And then here we have a magnitude 4.7, 1957. This is 1973 for 4.8. Then we have 1977 for a 4.8, and then a 4.8 in 2007. So all the same magnitude right there. And we see this very clear sequence in time, 1957, 1973, 1977, 2007. So there has been some regional change in the stress dynamics right here at this point where you have the bend and the most tectonic stress has been built up as a result of the plate motion between the Pacific plate and the North American plate. Now, if you go back to San Francisco, that ruptured the fault all the way up to Eureka. It's about 500 kilometers. And the shaking up there was quite intense. So that entire fault moved, displacing about 6 meters, but some evidence suggests that it was even like up to an 8-meter rupture, but it hasn't done anything since. And this earthquake here, magnitude 7.4, 1838, suggests that there's a higher recurrence interval perhaps for this location than, for example, further south with the 1857 magnitude 7.9 for Tihan earthquake. Now, this rupture in 1838 went from Monterey up to San Francisco, so it didn't hit those northern zones like 1906 did, but we see this progression. 1838, 1906, and then things have been silent now for 119 years. And so looking at this, I think this section here is the most likely to rupture in the near future with a big earthquake, magnitude 7.5 or greater. I have the magnitude 5 earthquakes that are the furthest up in our records here, so the most northerly, and you'll notice that they actually kind of form this fracture zone going in. So we had 2 magnitude 5.3s back to back. This is on October 1st, 1969, and then we see one here, 1893, magnitude 5.6. So there's a little bit of a zone there that gets earthquake activity, and then you'll notice these mountain ranges and everything just goes completely quiet until you get to that bend. There seems to be some sort of dynamic right here. Again, this is all the earthquakes. I mean, there's some other ones like further over inland that I didn't show. They're not that significant though, but as it relates to this section right there, this is it. Like, it's really a huge shadow zone. It's very, very odd. And then you get this zone up here at the triple junction with all the magnitude 7s. Now, another thing to keep in mind is that these earthquakes will generate a little bit of stress relief immediately in the vicinity near them. So they create an earthquake shadow, but then they'll also load stress further afield. So you have all this earthquake activity here at the triple junction, a lot of these being magnitude 7s. You consistently get magnitude 7s there, creating an earthquake shadow in this zone. And then you also get a lot of activity in the Bay Area. Here we're seeing a lot of magnitude 6 earthquakes, right? So I have those plotted. And in general, and we also had this 1906 creating a big shadow zone for this whole section there. These guys creating a bit of a shadow in that zone. The geysers are continuously rumbling as a result of the geothermal activity. So they're kind of always loading parts of this fault with new energy, because when you have an earthquake rupture, it loads some of the other parts of the fault with energy further afield. If you take the zones where that energy would add on to the stress dynamics, it's right at that bend. And we see that there has been earthquake activity there. And so just because the 1906 earthquake was there off the coast of San Francisco and it did rupture the fault all the way up to the triple junction, doesn't mean that this part of the San Andreas is only ever going to rupture with earthquakes down here. You could very well have earthquakes in this zone. And I actually think that this area here is probably the most likely to get a big earthquake soon. Somewhere right in this zone where you actually get the bend, I think you get a very large earthquake, and it's probably going to be close to magnitude 8. When that's going to occur, it's an unknown. But one thing you will notice is that a lot of these earthquakes are clustering around like the late 1800s. And so there seems to be maybe some connection to planetary resonances. The big earthquakes seem to cluster in time. That's very clear when you look across this record. I mean, here we have 1884, and then we also see 1878 and 1910. There is like a clear clustering, whereas some of the lower magnitude earthquakes are more evenly distributed. So that is the zone here that I think is the most likely to have a big earthquake in the near future. Though, of course, you also have, for example, these faults I talked about, the Calaveras, the Hayward Fault, the others. And you can't discount what is happening down here in SoCal. Well, this is more like Central California. And then you get SoCal. This whole area is ready to go. You see all these magnitude 7s that have occurred across time, and they do show clear sequences kind of traveling along the San Andreas Fault. If we go just a little bit further, we do see this quiet section here just south of Mexicali, right in the Gulf of California. This is magnitude 6, 1969, magnitude 6.2, 1953. No earthquakes in between there for magnitude 6 or greater. So that's a little bit of a quiet section too, which is interesting. And I didn't mark them out, but there's in fact a bunch of earthquakes that have occurred, of course, along the San Andreas Fault, all going through here. So I didn't list them all out because we're focused mostly on California with this video. It is worth pointing out this Great Cascadia subduction quake, magnitude 9, 1700, because this would cast a very large shadow. And it would also load the parts further out than that shadow. So you're going to get shadow zone probably going all the way to the triple junction, but then you're going to get loading right in that zone. Now that's back in 1700, and it did most recently slip in 1906 because of the San Francisco earthquake, but an interesting dynamic about how even activity further afield is influencing the regional earthquake dynamics in San Francisco. But these are the main zones I'm looking at. The big bends right there, they are locked and loaded, and we'll just have to wait and see when that next big earthquake occurs. It could be the moment I publish this video. That'd be crazy. It could also be decades from now, even perhaps longer. But in general, California has a very high seismic risk, and I'll keep you up to date as I continue to research into this more. So if you'd like to stay appraised, and please subscribe to the channel. That's what I do on this channel, is I give you information as to what is happening with the Earth. We look at geologic events, earthquakes, volcanoes, geomagnetic storms. We also examine, for example, space weather and solar activity, planetary resonances, and a lot more. So if you like the sound of that, then please subscribe. Again, I've been your host, Stefan Burns. Thank you all so much for watching. Wishing all of you well. I'll see you all in the next video.